Hi there, Miss Barber here. This lesson 2.1 is called Product and Quotient Rules. In this lesson, you will learn the differentiation rules for functions that are products or quotients. Let's have a quick review. For what are derivatives used? A few come to mind. The two important ones are 1, to find the slope of a tangent line to a point on the function, and 2, to compute the instantaneous rate of change at a point. Let's consider a motivating illustration for the product rule. Example 2.1.1. A. Find the derivative of f if f of x equals x to the fifth. Let's use our power rule for differentiation, and we know that that would be f prime of x equals 5 times x to the fourth. Part B. Find g prime of x if g of x equals the product of x squared times x cubed. Let's note that it is a product of two functions, so it seems like we might say g prime of x is that the derivative of the first function times the derivative of the second function. Well, that's 6x cubed. And let's observe that it is clearly different from the first derivative we obtained. We know that this is wrong. How do we find the derivative of a product? Well, we have a rule called the product rule for differentiation. It states, let f of x and g of x be differentiable functions, then d dx of f of x times g of x. This is read the derivative of the product of the function f of x times g of x. That is equal to d dx of f of x times g of x. That is the derivative of f of x times g of x plus, and then we'll have the first function f of x times d dx of g of x. Let's observe that the derivative of a product of two functions is the derivative of the first function times the second function plus the derivative of the second function times the first function. This rule is often written as y prime equals f prime g plus f g prime. I like to use the letters f and s. For example, if I say y equals first function times the second, then the derivative y prime is equal to the derivative of the first times the second plus the first times the derivative of the second. This derivative rule, as with all the previous ones we have learned, must be memorized. Example 2.1.2. Use the product rule to find g prime of x if g of x is the product of x squared times x cubed. Next, use properties of exponents and the power rule for differentiation to verify that the g prime of x we obtained using the product rule is the same as by using the power rule. First, with the product rule. The product rule states that if you have a function that is the product of two functions, then the derivative is the derivative of the first function times the second function plus the first function times the derivative of the second. Let's identify for our purposes the first function as x squared and the second function as x cubed. Now we'll find the derivative. The derivative of x squared for the first function would be 2x. Then we'll multiply it to the second function, which is x cubed, plus the first function we identified to be x squared, and the derivative of the second function, which was x cubed, is actually 3. We bring down the constant x and then raise to the power of 2. Let's simplify. For the first term, 2x times x cubed will be 2x to the fourth. And then for the second term, we have the constant of 3 and x squared times x squared, which is x to the fourth. Ooh, lo and behold, when we combine the two like terms, we get 5x to the fourth. That's how we did it using the product rule. Now, let's look at g of x, which is given as x squared, times x cubed. Now, we can combine those two terms and get x to the fifth. Rules of exponents tells us to add the powers if the basis is the same. And now, to take the derivative, g prime of x, using the power rule for differentiation, we bring down the 5. We have x, and then for the remaining power, 5 minus 1 is 4. And let's observe. They indeed do match. Example 2.1.3, find the derivatives of the following functions. A, y equals the quantity 2x to the fifth minus x minus 1 times the quantity 3x minus 2. We see that this is a product, so I'm going to identify the trinomial as my first function and the binomial as the second. Since we have to memorize the product formula, let's write it out each time we use it. That is, y prime is equal to the derivative of the first times the second plus the first times the derivative of the second. Now let's begin. The first function is 2x to the fifth minus x minus 1. Its derivative, we have 2 as the constant. The power is 5. So bringing down the 5, 2 times 5 is 10, times x to the 5 minus 1 is 4. And then we have minus the derivative of x is 1. The derivative of negative 1 is just 0. We don't need to write that. So we have the derivative of the first function, and we want to multiply it to the second function, which is 3x minus 2. Let's continue. Now for the second part, all we're going to do is write the entire first function, which is 2x to the fifth minus x minus 1. And then we need to take the derivative of 3x squared minus 2, which, let's see, the derivative of 3x is 3, and the derivative of negative 2 is just 0. Now that we've taken the derivative, we've got a little bit of simplifying to do. So let's do that. We have y prime equals, multiplying the first two terms together, we'll use the FOIL method. So the first terms, 10x to the fourth and 3x, would be 30x to the fifth. Outside terms, negative 2 and 10 would be negative 20, and then we still have x to the fourth. The inside term is negative 1 times 3x, so minus 3x. And the product of the last terms, negative 1 times negative 2, negative and negative gives us a positive. Product of 1 and 2 is just 2. And then let's distribute the 3 for the second part. So we'll have plus 3 times 2 is 6, and then we have x to the fifth, minus, distributing the 3, we get 3x, and again distributing the 3, you get negative 3. Now we can combine like functions, like terms, and we'll be done. So y prime is equal to, I see a 30x to the fifth and a 6x to the fifth, so adding those together, 36x to the fifth. I see only one x to the fourth term, so we'll write minus 20x to the fourth. I don't see any x cubed, I don't see any x squareds, but I do see two different x to the 1 terms, and that's negative 3x twice, so that'll be negative 6x, and then 2 minus 3 is negative 1. B, y of x equals 3x squared times e to the x. We need to use the product rule again, so let's write the product rule again. That is, if a function is equal to the product of two functions, say y equals the first times the second, then we know that the derivative of that product is going to be the derivative of the first times the second function plus the first function times the derivative of the second. Let's identify for the first function 3x squared, and for the second function e to the x. Now let's find the derivative. Y prime of x. The first function is 3x squared, so that derivative, we bring the 2 down. 2 times 3 is 6x, times the second function, which is just e to the x. And then we add that to write down the first function, which is 3x squared, and the derivative of e to the x is still just e to the x. Let's see if we can simplify this much. So we would have y prime of x is equal to 6x e to the x plus 3x squared e to the x. Part C, y equals x to the 4th times the natural log of x. This is also yet another product rule, differentiation. So let's go ahead and write that formula one more time. If y is the product of two functions, say first times the second, then the derivative of y is the derivative of the first function times the second function plus the first function times the derivative of the second function. We will identify x to the 4th to be the first function, and we will identify the natural log of x to be the second function. Let's take the derivative. Y prime is equal to the derivative of x to the 4th. We bring down the 4. Then we have x to the power of 4 minus 1, which would be 3. The rule says we just need to write the second function, which is the ln of x. We're going to multiply that, plus, and then the first function, we write it, x to the 4th, and then take the derivative of the natural log of x, which you have memorized, as 1 over x. Now, let's do some algebra cleanup. We have that y prime is equal to 4x cubed ln of x plus x to the 4th divided by x is just x cubed, and we can factor out the x cubed from both terms. So the final algebra step, factor out x cubed, and so for the first part you have 4 ln of x remaining, and x cubed divided by x cubed is 1. Part D, h of x equals the product of e to the power of x to the power of 3 times the natural log of the quantity x squared plus 3x. This is still another product rule property, so let's write the product rule for differentiation. That is, and we'll just write it by memory, if y is equal to f times s, then the derivative of y is the derivative of the first function times the second, plus first times the derivative of the second. For this problem, let's go ahead and identify that the first function will be e raised to the power of x cubed, and the second function, we will identify it as the natural log of x squared plus 3x. Now let's take the derivative. H prime of x. The first function is e to the x cubed, and we need to take the derivative of that, so we're going to use that special rule that tells us that's e to the x cubed times the derivative of x cubed, which would be 3x squared. And then just multiply the second function to it, so it'll be the ln of x squared plus 3x. And then for the second part, the first function, we write e to the x cubed, and the derivative of the natural log of, so the rule tells us it's 1 over the argument, which is x squared, plus 3x, and then we need to multiply it by the derivative of x squared plus 3x, which would be 2x plus 3. Now we're done with the calculus portion, but we do have a little bit of algebra cleanup. Let's go ahead and write that h prime of x is equal to, for the first term, we will have 3x squared e to the x cubed times the natural log of x squared plus 3x. And for the second term, looks like we're going to have the quotient 2x plus 3 divided by x squared plus 3x times e to the power of x cubed. You could factor out e to the x cubed, but it wouldn't make this any simpler.